Alright, today we're going to be focusing on operations of complex numbers in trig form. In particular, we're going to be looking at products and quotients and powers of complex numbers in trig form. So let's first find the product of two complex numbers. Okay, this is r cis A, r sub 1 cis A, and r sub 2 cis B. So I'm going to find a general formula to find any product. On our last video, at the end, and I know there were some on your homework, on the last one we found this product, right? We found this product. And it took a little time to get to our answer. We had to FOIL it out, combine like terms. Took a little time. It would be nice if we had a formula for how to do that. So that's what we're going to do. I'm going to derive this formula for you. Okay, so I want the product, so I'm going to multiply these two together. So I have R1 times cosine A plus I sine A, and I'm multiplying that by R sub 2 times cosine of B plus I sine of B. Okay, I know we can multiply these real numbers together. I'm going to write that as R1 times R2, R sub 1 times R sub 2. Now I'm going to multiply out, I'm going to FOIL out the parentheses. So I will have cosine A times cosine B plus I cosine A times sine B plus I sine A times cosine B plus I squared sine A sine B. Okay, so this becomes R sub 1, R sub 2. Okay, I see that I squared, and I know that that is a negative 1, right? I'm going to take that term, and I'm going to move it up after this term. So I'm going to rewrite cosine A cosine B, and I'm going to move this negative sine A sine B up here. So minus sine A sine B up there. And then I have these two. So that is, I'm going to take these two and just switch them and write the sine B first, but I'm going to write this one before I do that. So I'm going to write this as I sine A cosine B plus I sine B cosine A. Alright? Well, I'm hoping that this looks familiar to you right here. Cosine A cosine B minus sine A sine B is cosine of A plus B. That's that one formula that I needed you to know a couple of units ago. All right. So right now I have R1 R2 times cosine of A plus B plus, I'm going to factor an I out, and then I have sine A cosine B plus sine B cosine A. And hopefully that looks familiar to you, because that is sine of A plus B. So we have R1 R2 times cosine of A plus B plus I sine of A plus B, which is R1 R2 cis A plus B. So when we're multiplying two complex numbers together in polar form, we can just multiply the real parts together, and then we have cis of the first argument plus the second argument. From this we can very easily prove that the quotient of two complex numbers in trig form is the quotient of their r's times cis the top argument minus the bottom argument. It comes directly from that. And that's what's in this box right here. Okay, so as long as this bottom number is not 0, that is true. Okay, let's do some examples. Here we have 2 cis 3 pi over 4 times 6 cis pi over 12. We want to write this in reduced standard form. I multiply the real parts together, and then I write this as cis of 3 pi over 4 plus pi over 12. Let's simplify that sum. I'm going to get a common denominator of 12. 4 needs to be multiplied by 3 to get 12, so I need to multiply the top by 3 as well. Pi over 12 is still pi over 12. This is 12 cis 10 pi over 12, which is 12 cis 5 pi over 6, which is 12. Cosine of 5 pi over 6 is negative square root 3 over 2. Sine of 5 pi over 6 is positive 1/2 I. So this will be a negative 6 square root 3 plus 6i. Reduced standard form. Okay? A big time saver. And some things that we did not know how to find cosine and sine of, we can easily do with this process. Okay, let's do this one. Okay, well, the first thing I'm going to do is take care of my real parts. 4 times 9 is 36. Divided by 6 is 6. So that's just 6. Cis. Okay, now I'm going to take care of my arguments. The pi over 2 is up on top, so it stays positive. The 7 pi over 6 is up on top, so it gets added to the pi over 2. The 5 pi over 12 is in the denominator, so I need it subtracted from these other two. Let's clean up that expression, that argument. Common denominator is 12. 2 needs to be multiplied by 6, so I multiply the top by 6, plus 6 needs to be multiplied by 2, so I multiply the top by 2. This one will stay the same. So we have 6 cis, forgot my pi there, squeeze that in. This is 20 pi minus 5 pi is 15 pi over 12, which is 6 cis, let's see, 3 in both of these, so 5 pi over 4. That is 6 times cosine of 5 pi over 4 is negative square root 2 over 2. Sine of 5 pi over 4 is also negative square root 2 over 2. It's down there in quadrant 3. So this is negative 3 square root 2 minus 3 square root 2i. Make sure that your I is not under the radical when you write this, okay? It needs to be outside of that radical. Okay, what about this one? We are cubing this complex number. So I have 2 cis pi over 4 times 2 cis pi over 4 times 2 cis pi over 4. We're cubing it, right? So that's going to be 2 times 2 times 2, which is 8. Cis pi over 4 plus pi over 4 plus pi over 4. 3 times pi over 4 is 3 pi over 4. That will be 8 times cosine of 3 pi over 4 is negative square root 2 over 2. Sine of 3 pi over 4 is positive square root 2 over 2. and then I put the I there. So this is a negative 4 square root 2 plus 4 square root 2 I. Okay, let's generalize that. When we had that 3 out there, we cubed the 2, we cubed the real number, and then what did we do with that 3 for the argument? We multiplied it by that argument, right? That is de Moivre's theorem. That is de Moivre's theorem. If you are raising a complex number to an n power, you raise the modulus to the n power, and then you multiply the argument by the power. That's de Moivre's theorem. And here's a little history that you can read. It's a very interesting little history. You should do that. You should read that. I find that those little tidbits very interesting. A little background on these names. Okie doke. So if we have this, I'm going to cube the 4. Cube the 4, that's 64. And then we multiply 3 times the argument. When I multiply 3 by the argument, it's going to reduce with a 9, leaving a 3 in the denominator. And that is 64 times cosine of 5 pi over 3 is positive 1/2. Sine of 5 pi over 3 is a negative square root 3 over 2. Bring down your I. So this is 64 times 1/2 minus 64 times square root 3 over 2 is 32 square root 3, and then we have that I. Reduced standard form. One more. Cube your 5. I'm sorry, not cube. Raise 5 to the 4th power. That is 625. Cis. Okay. 5 pi over 6 times 4. Times 4. A 2 will reduce with a 6 in the bottom, leaving a 3 in the bottom, but I still have a 2 left on top, and that'll be 10 pi over 3. And that is 625 cosine of 10 pi over 3. Ooh, that's over 6 pi, so let's reduce it by 6 pi over 3, okay? Let's reduce that by 6 pi over 3. So that's the same as 4 pi over 3. Remember, those are coterminal angles. They are coterminal, so they have the same cosine and sine. So that will be 625 cosine of 4 pi over 3, that's quadrant 3, so negative 1/2. Sine of 4 pi over 3 is also negative, but square root 3 over 2. So this will be, in reduced standard form, negative 625 halves minus 625 square root of 3 over 2 I. Reduced standard form. Let's write this one in trig form. And then we're going to find the expression. So first I'm going to change it to cis form, and then I'm going to find the value of the expression in standard form. So in cis form, first of all, what quadrant is this thing in? Negative 3, negative square root of 3 is down here, quadrant 3. So I know that theta is going to be in quadrant 3, right? To get r is equal to the square of negative 3 plus the square of square root of 3 under the square root. That is the square root of 12, which is 2 square root of 3. Okay. And then for theta, tangent of theta is b over a, negative square root 3 over negative 3. So tangent of theta is positive square root 3 over 3. In quadrant 3, that means theta is a pi over 6 angle in quadrant 3, that is 7 pi over 6. So we have, for this expression, 2 square root of 3 cis 7 pi over 6 to the 4th power. Okay, let's raise 2 square root of 3 to the 4th power. Well, 2 to the 4th power is 16. What is the square root of 3 to the 4th power? Well, square root of 3 times square root of 3 is 9. And we have 4 square root of 3's. I'm sorry, square root of 3 times square root of 3 is 3. But we have 4 of those, so it would be 3 times 3, which is 9. So square root of 3 to the 4th power is 9. Okay, multiply 4 times 7 pi over 6. I'm going to think of that as 2 times 2 times 7 pi over 6. The 2 will reduce, leaving a 3 in the bottom, but I still have a 2, so 14 pi over 3. 16 times 9 is 144. And I want cosine and sine of 14 pi over 3, but that's above 6 pi over 3, so I'm going to reduce this. So 14 pi over 3 minus 6 pi over 3 minus another 6 pi over 3 would be minus 12 pi over 3. That will leave me a 2 pi over 3. So the coterminal angle here is 2 pi over 3. So we have 144 times cosine of 2 pi over 3 is a negative 1/2. And then sine of 2 pi over 3 is a positive square root 3 over 2. And then bring down my I. 144 times negative 1/2 is a negative 72. And then this will be a plus 72 square root 3 I. Okay, let's do one more. What if we have this thing? Okay, first I'm going to write this as 9 to the 4th. I really don't want to find out what 9 to the 4th is. It would be 81 times 81, and I can go off to the side and do that, but I think I'm going to work smarter, not harder. This will be cis of 4 pi over 3, right? Multiply that. 3 to the 6th, cis. 6 times 5 pi over 12 is 5 pi over 2, right? Okay, 9 to the 4th is the same as 3 squared to the 4th, right? So that is 3 to the 8th over 3 to the 6th, cis 4 pi over 3 minus 5 pi over 2. Subtract your arguments because we're dividing those. Okay, so 3 to the 8th over 3 to the 6th is 3 squared, which is 9. Common denominator time, the common denominator is 6. Need to multiply the 4 pi times a 2. Need to multiply the 5 pi times a 3. And we get 9 cis of 8 pi minus 15 pi is negative 7 pi over 6. What quadrant is that in? Negative 7 pi over 6 will be in quadrant. It's the pi over 6 in quadrant 2. So this is the same as 9 cis of 5 pi over 6, which is 9 times cosine of 5 pi over 6, negative square root 3 over 2, sine of 5 pi over 6, positive 1/2. So in reduced standard form, we get negative 9 square root 3 over 2 plus 9/2 I. Okay, that is operations of complex numbers.